Morning everyone. Today we're continuing writing and graphing exponential functions. So we're going to start off today by just doing a little review, writing function rules. The first one says to write a rule for our table here. So we need to look at where a is, what the value of y is when x equals 0. So x equals 0, that is right here. So when x equals 0, it looks like our a is -1 times b, what is being multiplied by each time? Well, if I look here, -1 to -4, that looks like it's being multiplied by 4. -4 to 16, that's also being multiplied by 4, so it looks like we're multiplying by 4. Now we always have to put 4 to the power of x, and all that equals y. So our rule is y equals -1 times 4 to the power of x. Here, when x equals 0, we have 0 and 5. So 5 is where we begin, times what we're multiplying. 5 to 10, that's being multiplied by 2. 10 to 20, that's being multiplied by 2. So we are multiplying by 2 to the power of x. So y equals 5 times 2 to the power of x. Here, if we're graphing these functions, we should draw a table so we know which ones to use here. We have x's and we have y's. Now I want to put a 0, a 1, and a 2, maybe a -1 and a -2, just so we have these here. So the first one, we would have -4 to the 0 power. Well, that's going to just give us 1. Anything to the 0 power is 1. Then -4 to the 1 power, that's going to give us -4. And -4 to the second power, or squared, that's going to give us a +16. Give me 1 second. Oh, -4 squared, that's going to give us a -16. Because what this is saying is that this is a -1 times 4 squared. So 4 squared times, or 4 times 4 is 16, times a -1 gives us a -16. Because we don't have parentheses, that's why we are not multiplying the -4 times -4. So we have to do -1 times 4 squared. Now, if we put the next one into our calculator, -4 to the -1 power, that gives us a -0.25. And -4 squared to the -2nd power gives us a -0.0625. So if we're going to graph this, then we start at 0. Let's see. Oh, this would be a -1 because we're multiplying by -1. Sorry, guys. So 0 is going to -1. Then at 1, it's going to -4. We can't go to 2 and -16 because we don't have that on our graph. but we can go to -1 and -0.25 and -2 and -0.625. So it looks like we are going down as we're going left to right. So this is a decay function. This is an exponential decay function. Now it says to define the domain and range too. So the domain is the numbers on the x. We could pick any numbers that we wanted to for the domain. So I'm just going to say that this is all real numbers. The range, well, that is all the negative numbers because we never go past 0 to get to the positive. So what this is all negative real numbers. Alright, I want you guys to try this next one on your own. So graph that, draw a table, find the domain and range. If you're getting confused, make sure you put these numbers in your calculator to get your exact answers. Alright, next one. We are graphing 3 functions here. So we're going to graph 3 functions. We're going to compare them to y equals 2 to the x power. So let's start with that one. Y equals 2 to the x. Well, if we start with 0, 2 to the 0 power is 1. 2 to the 1 power is 2. And 2 to the 2 power, that's 4. 2 to the -1 power, that's going to give us 1/2. Put that in my calculator to make sure. Yep, that's 0.5. And 2 to the -2 power gives us 0.25. So if we're going to graph that then, start at 0 and go to 1. At 1, we're going to 2. At 2, we're going to 4. -1 is at 0.5. And -2 is at 0.25. So we can connect these dots by drawing an exponential function there, a curved line. And that is the graph that we are comparing all of the rest of ours to. Here we have 3 times 2 to the x. Well, if we start where it was 0 and put 2 to the 0, well, that's still going to give us 1, but now we're going to be multiplying it by 3. So 1 times 3 is 3. If I put in 3 times 2 to the 1 power, that's going to give me 6. 3 times 2 to the 2nd power, it's going to give me 12. 3 times 2 to the -1 power is 1.5. And 3 times 2 to the -2 power gives us 0.75. So if we were to graph this one at 0, we start at 3. At 1, we have 6. That gets us off our graph. It's about there. And 2, we can definitely not fit that on our graph. But at -1, we're at 1.5. And at -2, we're at 0.75. So if we were to connect those, now if we compare just those two graphs, this is our original graph, This, if we compare our red line to our blue line, what's happening is we started up farther than the blue line. So what happened is we stretched this vertically. We stretched vertically for this one, for this graph. Alright, so if we look at this next one, it's negative 3 times 2 to the x. So 2 to the x is times 0. That's 1 times negative 3 gives us a negative 3. Negative 3 times 2 to the 1 gives us a negative 6. This one's just going to be the same thing as this. So negative 3 times 2 to the negative 1 gives us a negative 1.5 and then a negative 0.75. So at 0 here, this one starts at negative 3. At negative 1, we have negative 1.5, and negative 2 is 0.75. Then we would draw our line like that. Now what's happening here, this is also being stretched vertically. That's also being stretched vertically, and also now this is actually a decay function instead of a growth function, so it's going negative. So what that's called is a reflection of our original. Instead of going positive, it's going negative now. Alright, so now we have another exponential growth model. So what we have here is basically the same thing, except now we're looking at time periods and rates. So here it says that A is the initial amount. A is where we start, just like before. R plus 1, or 1 plus R, that whole thing, this whole thing here, is the growth factor. R is the growth rate, and T is the time period. T is the time period. So we are going to make sure that we write our rate as a decimal when we try these problems coming up. So let's give it a try here. So it says the owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in 1984 when its value was $11,000. The value of the car increased at a rate of 6.9% per year. Write a function that models the value of the car over time. So what we are going to start with, well, we have y, and we said that A is the initial amount. So our initial amount is when he bought it right away at $11,000. Then we got to look at what's in the parentheses. We know we have 1 plus our rate. So it's increasing at a rate of 6.9 per year. Now this is a percent. We want to write it as a decimal. So as a decimal, 6.9% per year, that is 0.069%, all raised to the power of t. We don't know the time yet. So what we have is 11,000 times 1 plus 0.069 raised to the power of t. So we are going to use that function rule to answer B. It says the auction took place in 2004. What was the approximate value of the car at the time of the auction? Round your answer to the nearest dollar. So we're going to take our equation, y equals 11,000 times 1 plus 0.069. Now our time changes now. So it says the auction took place in 2004. When the owner bought it, it was 1984. So the time has been 20 years. So what we need to do then is put this into our calculator to figure out our answer. So we would have 11,000 times, in parentheses, make sure you write it exactly as you see it on your paper. So 1 plus 0.069 raised to the power of 20. So this car, over 20 years, grew. It started at $11,000. Now it's $41,778 by rounding it to the nearest dollar. So this car over time gained value, and now it's worth $41,778. Next one, we are talking about saving money, something that you guys might want to start doing once you start getting jobs in the next couple years. So it says you put $250 in a savings account that earns 4% annual interest compounded yearly. So every year you're getting 4% interest. You do not make any deposits or withdrawals. So how much money will your investment be worth in 5 years? Well, let's see. We start with y equals A is the amount of money you put in right away. So you put in $250 right away. Over time, it's 1 plus whatever your rate was. Your rate was 4%. That written as a decimal is 0.04. And we want to know the time, and our time is 5 years. So we need to answer this. How much money are you going to have in your savings account over 5 years? So if I'm going to put this in, it would be 250 times 1.04 to the fifth power. Now 1.04 to the fifth power gives us 1.217-ish times 250. That is going to equal 250 times 1.217 gives us $304 and about 25 cents. So our answer, the closest one we have to this, would be B. I'm just going to re-enter this in my calculator to make sure that that is right. So I want to check my answer. And it gets me to $304.16. So you put $250 in. If you don't do anything with that money, after 5 years, it will be worth $304.16. Next one, for college tuition. From 1995 to 2005, the tuition at a college increased by about 7% each year. Use the graph to write an exponential growth function that models the tuition over time. So it looks like we have y equals, now a is where we start, looks like we started at 8,000 because we have 0 to 8,000, that's where we start. We are multiplying by 1 plus, now we know our rate is increasing by about 7%, so 0.07. And we know our graph is going from 1995 to 2005. So we could find this to the power of 10 to see what our tuition is going to be in 10 years. So if we were to put this in our calculator then, it'd be 8,000 times 1 plus 0.07 to the 10th power. Over 10 years, it increased to $15,000, 737.21. So in 1995 it started at 8,000. Now in 2005 it's $15,737. Last one. We are going to graph y equals 2 to the x. Well, 2 to the x to the 0 power, that's going to still be 1. To the 1 power will be 2. To the 2 power will be 4. 2 to the negative 1 is going to give us 0.5. And 2 to the negative 2 is 0.25. So at 0 it's 1. At 1 it's 2. At 2 it's 4. Negative 1 is 0.5. And negative 2 is 0.25. So that is our first function that we are going to compare to. Next one, we have a negative 1/3 times 2 to the x. So 2 to the 0, let's start there, is 1 times negative 1/3. That's going to give us a negative 0.33. If we put in negative 1/3 times 2 to the 1 power, is going to give us a negative 0.66. Negative 1/3 times 2 to the 2nd power gives us a negative 1.33. Negative 1/3 times 2 to the negative 1 power gives us, one second here, negative 0.16. And finally, negative 1/3 times 2 to the negative 2nd power gives us a negative 0.08. So we have a lot of very small numbers on this one. So if we start at 0 and go to negative 0.3, that's about right there. Negative 1, or 1, is negative 0.66. That's about there. Negative 2 is at negative 1.33. And we're getting even smaller for the negatives. So this is stretched vertically because we are moving it away from our original. And it's also a reflection because this one is a decay function instead of a